Okay, so in this video here, we're going to be talking about how to derive the quadratic formula. So a lot of students know how to use the quadratic formula, but very few know where it actually comes from. And it's a question that gets brought up sometimes because yes, you may know how to use it, but knowing where it comes from is also very important. Now, in order to understand this video here that I'm about to do, you have to understand completing the square. Okay, and I have videos on both completing the square when a is equal to 1 and completing the square when a is not equal to 1. And when you complete the square, you're doing that because you're trying to solve a quadratic. Or you could be trying to get the equation of a circle, but that's another video. But when you're dealing with quadratics and you complete the square, it's because you're trying to find the zeros. So I'm telling you that because the quadratic formula, this thing right here, which we're all familiar with, comes from completing the square. Okay, it's derived from completing the square. I'm going to show you how that's done. So you can think of the quadratic formula kind of like the little brother of completing the square. Okay, so make sure you're good on completing the square. And assuming you are, we are going to go ahead now and derive the quadratic formula from completing the square. So I have a clean slate here. And first, we want to talk about what is a quadratic in standard form. And that is going to be ax squared plus bx plus c. Okay, and we know that when we complete the square, we want to be in the following template, which is x squared plus or minus bx equal to c. Okay, now this plus or minus here is indicating that that bx term could be either positive or negative. Okay, now notice here in front of my x squared, I don't have anything. Okay, but if I look at my quadratic in standard form, I have a coefficient of a. Okay. So this value that needs to occur right here always has to be 1. So our first step of deriving the quadratic formula is to put it in this format right here. Okay. So in other words, I have to take this c term and I have to move it over to the right hand side. Now remember, this is all equal to 0. Okay. So first step, let's take that c term and move it all the way over to the right hand side because that's my constant, right? And we need our constant on the right hand side. So let's go ahead and do that. And now we're going to have ax squared plus bx equal to a negative c. Okay? So what do I do from here? Well, typically when you complete the square, you have to make sure that a is equal to 1. Now I'm dealing with variables here. Okay? I can't just assume that a is going to be equal to 1 here. Okay? In order for the formula to work out. So as a result, I'm going to have to factor out an a between this term here and this term here. So when I do that, I get the following. I'm going to get an a, and then in parentheses, I have x squared plus b over a, and then x. And then close it equal to negative c. So you can see that if I distribute this a, I'm going to get what I have up here. Okay? Again, the a's will end up canceling out on this second term. You'll be left with bx. Okay, now what? Well, from here, now I have to do b over 2 squared on both sides. All right, so I'm going to write this over here in a different color. We're going to do b over 2 squared. Now my b is ba. This is my b right here, ba. So I'm going to do b over 2, and I'm going to square it. So this will be equal to my b, which is b over a all over 2, and then squared. This will be equal to, well, what do we get here? Now remember, keep, change, flip. This stays the same. I'm dividing, and it's a 2. So it's really b over a, change it to multiplication, and then 1 over 2. Okay, that's what's actually going on here. So you're going to be left with b over 2a. So b all over 2a, and we still have to square it. Okay? And this will be equal to b squared all over 4a squared. Okay? Remember, this exponent has to be applied to both your numerator and denominator. So you're doing b squared and 2a squared. That's where you're getting b squared all over 4a squared. Okay? Now, I want to go ahead and underline this part right here. This is b over 2 simplified. You know that when you complete the square, when we put it back in factored form, this value right here, b over 2 simplified, will always be the value that you use when you put it back in factored form. So we may or may not need this in this problem, but I'm going to go ahead and underline it anyways because it's good practice, okay? So I'm going to leave that there. And so now I have to add b over 2 squared on both sides. So for me, that's going to be b squared all over 4a squared. So doing that, we get the following. I'm going to get a. Again, that a is just coming along for the ride. What we're really doing is this part right in here, okay? So we're going to get x squared plus b over ax. And now here's my b over 2 squared. I get plus b squared all over 4a squared, okay? Close it, equal to. Now I have to do it on the right-hand side too. So I'm going to do negative c. Now be careful here, okay? What did you actually do? Well, I did b squared all over 4a squared. And if I were to distribute this a, right, I'm going to go to each one of my terms here. When I get to that third term, look what ends up happening. One of the a's will end up canceling out, okay? So for example, when you write it on the right-hand side, you're actually going to write it as plus b squared all over 4a. Just like that, because again, one of the a's will cancel out, okay? So now what do? Well, typically when we complete the square, right, we want to go ahead and factor and then solve. So that's exactly what we're going to do here. Remember, the goal is to solve for x. We want to solve for x, okay? So we're going to go ahead and factor it. Now, can you imagine trying to factor this part if you didn't know what the value was going to be? Luckily, we underlined it right here. It's going to be b over 2a, okay, when we factor it. That's how it always works out. So I'm going to be left with a, and then in parentheses, I'm going to have x, and then plus b over 2a, and then square it. Okay, that's done. We just factored it. So if you were to expand that out, you're going to get what you have above there. All equal to negative c plus b squared all over 4a. Okay? All right, I'm going to start a new page so we can continue on with the problem. We're almost done. Okay, so I just went ahead and rewrote the problem. That way we have room to continue on here. And so from here, what do we need to do? So again, the goal is to solve for x, meaning I want to solve for this guy right here. Okay, before I can do that, I have to get rid of this a. Okay, this a is being multiplied, so the opposite operation there would be division. So to get rid of it, I'm going to divide both sides by a. That will cancel out here. Now I have to do it to both of my terms. Divide this by a and divide this whole thing by a. Okay, so I end up with, in parentheses, x plus b all over 2a squared equal to negative c all over a. And then what happens here? So if you have to, write it out as keep, change, flip. You're really doing b squared all over 4a. You're dividing, so we're going to change it to multiplication, right? And then the a is really a over 1, so we need to flip it. It's 1 over a. So now we get 1 over a. And then from here, we just multiply across and we get the end value. We get plus b squared all over 4a squared, okay? So right now it's looking pretty messy. What I want to do right now is I want to combine these two terms, okay? I don't want to have two terms hanging out like that. I want to combine them all into one. So in order to do that, I need a common denominator, okay? Well, I already have an a, right? I have an a here and I have an a squared here. So all I really need to do is manipulate this fraction right here. And all I'll have to do is multiply both the top and the bottom by 4a, and that will give me the common denominator that I need. So that's what I'm going to do. I'm going to rewrite the problem. I have x plus b all over 2a squared equal to, so again, I'm going to multiply this fraction right here, both bottom and top, by 4a. And that will give me negative 4ac, right, all over 4a squared. And then plus b squared all over 4a squared. So from here, I have the common denominator that I need. I can just go ahead and combine my numerators and write it all underneath the same denominator. Okay, so for example, now you have this. X plus b all over 2a squared equal to negative 4ac plus b squared all over 4a squared, okay? All right, so you can see that we kind of have something that looks like the quadratic formula. We're almost getting there. From here, we have to take the square root on both sides, right? I have to get rid of this exponent value. My goal is to solve for x, okay? So I'm going to take the square root on both sides, and how is that going to look? Well, I'm going to take the square root here, and I'm also going to take the square root here. That will cancel out this exponent value here. That's what we want. So I'm just going to go ahead and divide this up so I have room to continue on with the problem. All right, I'm going to be left with x plus b all over 2a equal to, now remember, this square root is being applied to both the numerator and denominator, okay? So on my numerator, I'm going to have the square root of negative 4ac plus b squared, okay? And then all over, again, I have to take the square root on the denominator as well. But if I take the square root of 4a squared, well, the square root of 4 is 2, and the square root of a squared is a. I'm left with 2a. And now remember, you took the square root. So whenever you take the square root, it's always going to be plus or minus. So what I'm going to do here is write plus or minus, okay? And so what they did with the quadratic formula, they rearranged the terms to make it a little easier, to make it a little more organized. So you can see inside here, typically with the quadratic formula, it's b squared minus 4ac. So that's how we're going to rewrite it. That's fine. I mean, this is the same thing, but we're going to write it the way you typically see it. And then we just have to take this b over 2a and move it over. So we can actually do that all in one go. I'm going to have x equal to negative b over 2a, just moving this over, right? And then I have plus or minus square root of, we're going to rearrange the order here. It's going to be b squared, so positive b squared, right? And then minus 4ac all over 2a. And this is actually done, but since we have the same common denominator, we can combine our numerators now and write it underneath the same denominator. So here's our final answer. Let's go ahead and do it in a different color. We get x equals negative b plus or minus square root of, and then we get b squared minus 4ac all over 2a. And there it is. There's the quadratic formula. So we're going to go ahead and box that in. And so if you were ever curious where the quadratic formula came from, it comes from completing the square. So you can think of the quadratic formula as the little brother of completing the square. I mean, technically, every time you use the quadratic formula, you're technically kind of completing the square since that's where it came from, right? So I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.